Hello, good morning to everyone. Do you want in English or Italian? What do you prefer? English, okay. Let's go. Okay, we are here today to talk about AI and what we can do to improve the speed, reduce the latency, and an overview of what's around. Obviously, it makes sense if you are working on our AI project using maybe an open source model and not just a wrapper on ChatGPT that, okay, cool, but it's not making AI, it's using AI, integrating AI. Why so speed is important? Because people using big companies' models are now have the habits to have really, really good performance. And if you want to give a product or a service that is comparable, not equal because we don't have 10 of billions to build, but comparable, we must focus on give a good user response, fast user response. It has to be correct and it has to be fast because people, okay, it's not responding. Why? So the first thing a customer can say if it's slow, okay, oh, why? OpenAI goes faster, okay, thank you. Real-time AI, okay, we are developers, we know it's not really real-time, but the title was cool, so I added the bracket, okay? And that's our goal. The word is latency. I know everybody knows. What is it? Don't have to explain it, okay? But as we said a few moments ago, for the user experience, even some seconds or worst minutes of latency are a really, really poor experience and a really, really bad feeling about our product, even if on the, on the background is doing really cool stuff. But if the user cannot have it fast as they expect, it could be, downgrading our product. So, first thing, we can act working on the models we are using. It's cool, we have Llama, 60 billion parameters, it's multimodal, it can do images, it can do really a lot of things. But if you are using it just for a chatbot, why do we need this billion of function just to have a chatbot? So there are mainly two methods to make it work faster without losing, with a compromise, without losing too much. The first one is the distillation. It's called distillation. Distillation is the procedure when we can train another model taking only the data we need from the bigger one. So we have a sort of teacher and student relations. We can imagine Llama 70B and tell him, okay, give me the instruction to train a smaller model that is only mechanical engineer. Because we want the specific model to help, a mechanical company that have to do maybe projects and calculation on their projects. So we don't need that he has skill on law, on marketing. And it really, really reduced the size of the model that we're going to use, and it obviously is faster. Another one that I don't like very much, but is most used, again, if you go on Hugging Face, you can find a lot of quantized model. And they are made basically to make it run on CPU or in PC with not so high performance. Why? Because simply it reduces the size of the number inside the model. So usually LLMs work with 32-bit numbers and are really big. We can have a lot of, and you can cut off the size of the nodes and it works faster. Obviously, there will be a flattening of many variables, many values inside the model, and will be minus precise. But if everyone has tried to run all Llama on their PC, 1, 2, 3, 4, okay, everybody, okay. So you know the difference, you can see the difference, okay, even for basic questions or basic tasks that you can perform in the full model. But there is another solution. Small language models. This is cool because obviously people and companies catch the requirement to have small models that perform small tasks but efficiently. And some cool came around. So Qwen 0.5 billion, Microsoft PHI-3, Tiny Llama, Model Llama, Gemma, Google. So if anybody has Android from the 14 version, it has Gemma inside. They call it Gemini, but really it's Gemma because it's working offline directly on the phone. And it does just the basic things he has to do. Text-to-speech, speech-to-text, answer to question, and send commands to the Android interface to launch apps. Nothing more, what is needed in this kind of model. This could be because we can make it run also on edge devices that we are going to see now. Edge computing. This is this thing exists from years. We have been in the era of data center and ET administrator with on-premise and edge computing. Then people moved to cloud, and now we're going back. Why? The first reason is for the data protection, the main one, because companies are avoiding employees to use ChatGPT or Claude because they are putting almost everything on them. Intellectual property, secret projects, information that doesn't absolutely have to go outside the company. So the edge computing, we can put some machine on premise, and the language model can run inside the company without never going out. That's so important. Obviously, the latency is reduced simply because the cable is shorter. So simple, okay? And this is the future. Not only in my opinion, but also many people involved in AI are looking at edge computing for AI distribution models, especially if you don't want to go with Claude or ChatGPT or other. Edge AI involves the use of spatial architecture, hardware architecture. Everybody knows the GPUs, why they work so good with the AI, because they are optimized for parallel calculations of simple operations. So really high volume of data, but simple operations. Then I've developed some specialized architecture, like the TPU, that is the tensor processing units made by Google. And this is not a processor, but is an ASIC, so an application-specific circuit, and is properly optimized to work on tensors. Tensors is multi-dimensional data representation, and this is really optimized. But you cannot find it in any shop. You have to go to Google, and they don't give to anyone access to this kind of device. They use it only for their cloud, their recognition services, and Google Vision, and so because, the tensor for images is perfect, because in a matrix array, okay? And they are designed also for the training, machine learning, neural networks that are, everything that is under the AI. Then a couple of years ago, it does become famous with Grok, a company that offers really low latency inference. This is the LPU, Language Processing Unit. And this kind of ASIC are designed especially for the language model-related operation, inference on LLM, text-to-speech, speech-to-text, and other kind of operation that are involved in this kind of development. They are starting to come out. So if you make a research online, not in Italy, not in Swiss, but you can go in USA or China, you can find some device with LPU on board. It requires a special compilation, but it could be. We have one cool choice that maybe someone has already talked about this morning, that is the NVIDIA Jetsons. The NVIDIA Jetson, this kind of box, is like a big Arduino, big Raspberry. That is so cool. It costs hundreds of times, okay? But it's equipped with GPU NVIDIA. Inside a special operating system based on Ubuntu that is specially designed to run the Jetson containers. They're basically like, containers, but specialized on this kind of architecture. So we can have one container with LLM, one container with text-to-speech, and in a kind of orchestration and microservices that talk each other in a box that is like this. Really, really good speed. You have to add an SSD, okay, but This is where the world is looking at, especially with NVIDIA that announced 2 weeks ago the new supercomputer digit that will come out in May. This is based on this one. This is the father. I am your father. Second thing we can do to optimize the latency, but it is common with every other application, batch processing, so split the operation processing in multiple batches, asynchronous pipelines, the parallel processing of various steps of the operation. If everyone has ever tried the OpenAI or 11 Labs real time where you talk, it's so fast because it's parallel processing. While one process is getting out the output, the other one is producing, so it's a lot of parallel. Embedding caching. It's caching, standard caching, but it cut off all the computation time to create the embeddings. That is the conversion from the text to the vectors, basically, used in the LLMs. So we can use a kind of on-the-fly RAG. We have a knowledge base where people 80% of time make the same question and get the same answers. But we cannot assume they make exactly the same question. We cannot memorize an hash or the text. With embeddings, we can make on the fly a similarity search, and let's see if we have something in cache. Also, GPT and Claude use these techniques. Sometimes when you're chatting on, you can see, okay, cache updated. That's the reason. And use specialized models, as we said a few minutes ago. Okay? That's cool because we made a chatbot, for some pharmacies. And they had about 2,000 requests per day, to reservation of medicines and visits and, information about all the stuff they do in the pharmacies. And they had a standard chatbot based on a provider. I don't cite the name. But with the improvements this way, we get a really, really customer satisfaction boosted because, they had it on WhatsApp, and then the system was going to produce the entire response before putting out really long responses. So people is writing, okay, and some of them drop off the chat because it doesn't make response. This response arrived maybe 30 seconds later. And with the performance, just adjusting some of the pipelines without refactoring totally the system, just adjusting something, it really get faster and cooler. Fun fact, a second or 1,000 milliseconds, okay, it is really a small part of our day, but multiplied for thousands or hundreds of interactions is really long time. So I think it's one thing that who works in this field must focus on. Okay? For all the reasons we already explored in this short talk. Okay, this is one the same we have said before. I cut off, we have 2 minutes. Is it? Okay, so recap. What can we do to make our AI project faster and better performance? Optimizing pipelines, so parallel processing, using batch operation, caching, all focused on reducing latency. That's also why ChatGPT gives the response tokens per tokens. So when you get via API the response from Claude or ChatGPT, you get piece of the words token per token, not the entire response once, okay, all together. And if we are working on edge computing, use hardware with specialized processing units. We cannot distribute a system on-premise with all llama, with a quantized models, because it must run on a VPS, classical VPS, or a CPU server. It doesn't make sense. That's it. Ask me now, or wait 5 seconds. There is a lot of time. Yeah. Microphone.
A rookie question. How do you distill a model?
Okay, you can produce the training data from the bigger model, just telling him, okay, I want to make a distillation of you on these tasks, on these topics. Give me the data in this format that is basically usually question and answers about. And the bigger model produces all the data, and you use it to train the other one.
So it's just a prompt?
Yeah, basically the start is obviously later you have to train the other one, but that's the basic.
Thank you.
Okay. Everybody happy?
Thank you again.
Okay, grazie. Thank you.